In this video, I'm going through S1, Chapter 2 and Section 2.2, which is Measure of Central Tendency. A measure of location is a single value. So measure of location is a single value, let's take that off, which describes a position in the data. So for example, the median is a measure of location and it describes a particular value with a particular position in the data, and that is the middle position. If the single values describe the center of the data, it is called a measure of central tendency. You would already know how to work out the mean, the median, the mode of a set of ungrouped data, that's data from a list, and from ungrouped and grouped frequency tables. The mode or the modal class is the value or class that occurs the most often. The median is the middle value when the data values are put in order, and the mean is calculated by adding all the values together and dividing by n. Now, the symbol for the mean is x bar, and this of course is sigma x, and that means I am adding up the x values, the data values, and n is the number of data values. The book also has something about the combining means. This just means that I'm going to add the total number of numbers multiplied by the old mean for the first data, then I'm going to multiply the new number of numbers by the mean of the second data, and I'm dividing by the value of n1 and n2 to get the mean. Now, this is much simpler when you just have a look at an example. This is still very much GCSE. The mean of a sample of 25 observations is 6.4. Well, what's total 1? That's basically what I'm trying to find here, is find the total of the first set of data. Well, if the mean is 6.4 and the mean came from the total divided by n, okay, to give me the mean. So to do the opposite would be n times the mean. That's what the formula above did. So the new total is 25 times 6.4. and that would give 160. And then it says the mean of a second sample of 30 observations is 7.2. So I'm trying to find the total for the second observation. So that's 30 times 7.2, and that's 216. Well, what's the total for both observations or both samples? Well, that's 160 plus 216, which is 376. And then it says calculate the mean of all 55 observations, and that's the 25 plus 30 makes the 55. So they've done that bit for you. So the new mean is going to be 376 divided by 55. 376 divided by 55 gives us a long decimal number. So since they've given me the old means to one decimal place, that's what I'm going to do. So 6.67, and the 7 rounds up. So that means the new mean is 6.6. 6.7. 6.7 when we round up. So that's still very much GCSE. Now, this talks about how to find the mean, especially from grouped or ungrouped frequency tables. And you know all of this, but we'll go through it. The mode is used when data is qualitative or when quantitative with either a single mode or two modes, bimodal. If there are two modes in the data, it's called bimodal. There is no mode if each value occurs just once. The median, this is used for quantitative data. It is usually used when there are extreme values, as they do not affect it as much as they affect the mean. So the median is good to use when there are extreme values or outliers in the data. The mean is used for quantitative data and uses all the pieces of data. It therefore gives a true measure of the data. However, it is affected by extreme values. Okay, so let's look at the first example. Lee Y records the shirt collar size X. So I've put that here. X is the shirt collar size of male students in his year. The results are shown in the table. For these data, find the mode, the median, the mean, and explain why a shirt manufacturer might use the mode when planning production numbers. So at GCSE, you would have got a table that looked like this, and you would have had to create an extra column, and that extra column is basically the data X times the frequency to get to that third column. And I'm going to type it because OneNote is going to do this rather quickly for me. So I need to multiply. There are 3 people, basically frequency 3 people who have a shirt collar size of 15. So altogether we have 45. And then I have 15.5 times 17. And I have 16 times 29, and I have 16.5 times 34, and I have 17 times 12. So I've got all of these, and what I now need to do is to add these numbers up. Now, you don't need to create a table from scratch. If you look in your textbook, the working looks something like this. 15 times 3 plus, because we're going to add them all together, 15.5 times 17 plus, etc., etc. And then all together we must divide them, and you can put that onto your calculator straight away. But I just chose to put it in a way that you have seen before to show you that we're pretty much still in GCSE territory. So we're adding 45 plus 263.5 plus 464 plus 561 plus 204. And that gives us 1537.5. You also need to add the frequency. That's the number of numbers that we're going to divide by for the mean. So 3 plus 17 plus 29 plus 34 plus 12, and it gives us 95. So your mean is going to be 1537.5 divided by 95. And again, it's a long decimal number. I'm going to give it to one decimal number, which is one decimal place, which is 16.2. That's the shirt collar size. Okay, so that is the mean. The mode is the size that appears the most, and that is size 16.5. It's not 34. 34 is the frequency. It's the number of people who have that size. So it's 16.5. Because it appears the most, it appears 34 times. The median requires a cumulative frequency column. Sometimes the easiest thing to do for cumulative frequency is either to do it with your calculator, or if you've got your own table and you want to, let's move these over there. It's just to use that column, really. So how many people have a size 15, which is the smallest size, or less? Well, 3 people. And then I'm going to add the 17, so that gives me 20. And I'm going to add the 29, so that's going to give me 49. And then I'm going to add the 34, and that's going to give me 83, and I'm going to add the 12, and that's going to give me 95. So you can see that's a cumulative frequency column. And for the median, I know that I have 95 numbers. For S1, to find the median, most of the time, and I'm going to show you when you don't have to do it, is you add 1 and then divide by 2. I don't know if you've seen the add 1 method or not. You add 1, you divide by 2, and this tells you that the median is the 48th value. Now, where's the 48th value? Well, we've got 3 values here, and then that gives us 20 values, so it's definitely not there. But then, from here to there, that goes from the 21st to the 49th value. So the median is 16. The median is a size 16 color. Now, you can do it on a calculator. You can say, well, 3 plus 17 is 20, plus 29 equals 49, and I want the 48th. So it's not at the 20 mark, it's the one after it gets us to 49, so it's there, it's 16. You can create a different column, or you can do it just on a calculator. The reason we add 1 is, for example, if you have a set of if the number of numbers in your data is odd, so that's 3 numbers, you know that there's going to be only 1 value in the middle. But if I do, well, I know I have 3 numbers. 3 divided by 2 is 1.5. That's not helpful. So what you're going to do is you're going to say, well, it's 3 plus 1 divided by 2. That's the second value in the data. Here it is. Yes, it's the second number in the data. Now, if you have, if the number of numbers is even, so 5, 6, 10, and 15, that's an even number of numbers. When you're finding the middle, you end up with 2 values. So what happens here is I do the following. I say, well, this 4 numbers plus 1 divided by 2, which is 5 numbers divided by 2, so that's 2.5. That tells me that the median is between the second and the third numbers. So you would get those second and third numbers, add them up, and divide by 2 and find your median. So that's why we add 1. Some people teach it differently without the add 1 as well. So we've got the mode, we've got the median, and we've got the mean, and we want to explain why a shirt manufacturer might use the mode when planning production. Well, the mode is the most popular shirt size. That's what it means, the shirt size that is bought the most. And the manufacturer needs to know that to produce enough shirts. They want to sell, and they want to produce the most popular size so that they can sell more. So you can give this reason in your own words, and it will have to be a reason in the context of the question. The second example is an example of a grouped frequency tables. These are called groups or classes. And before you're able to find the mean, you have to find the midpoint. And the midpoint is found by adding the upper and lower limits, and then dividing by 2. So if you have to put, if you're going to do it on a calculator, if the numbers are not clear, then you have to put it in brackets so that BidMass doesn't take over. But it is clear that what's between 30 and 31 is 30.5. And between 32 and 33 is 32.5. And between 34 and 36, you have to read carefully, the groups can be different, is 35. And between 37 to 39, it's 38. And then you would do these two columns together. So that's 2 times 30.5, which is 61. That's 25 times 32.5. That's 30 times 35. That's 13 times 38. So 25 times 32.5 is 812.5. 30 times 35 is 1050. And 13 times 38 is 494. And again, to find the mean, you have to find the total of the frequencies and the total of f of x as well. So that is 70. And then I'm adding all of these up, 61 plus 112.5 plus 1050 plus 494, and I get 2417.5. And to find, it says an estimate for the mean. It's an estimate because we don't actually know whether these two people both took, these two pine cones, whether they're both 30 millimeters or they're both 31, or one of them is 31, or one of them is 30, or one of them is 30.5. We don't know. So we've estimated because we've used midpoint values. So that's why. So why is it an estimate? It's an estimate because we've used midpoint values. Used midpoint values as an estimate for the data. Because we don't know what the data is, because it's grouped data. So that's going to be 2417.5 divided by 70. And that is 34.5 to 1 decimal place. And then for part A, it says write down the modal class. Where's the class that appears the most? It's this one, because it appears 30 indeed. That one appears the most, it appears 30 times. And when you copy the class or the group, you copy it exactly as it is. If it has a dash in the middle, that's what you copy. If it's an inequality, then you copy it exactly. And then for the last one, it says find the median class. And I'm going to, when it's a grouped data, we're going to use 70 plus 1 as well. So 70 plus 1 over 2. And that is going to give us 71 divided by 2, which is 35.5. So I'm looking for the 35th value. Basically, it's going to be between the 35th and the 36th values. So let's have a look with our calculator. It's not going to be there, because there's only 2 values here. Plus 25 gives us 27, so it's not going to be there either. Plus 30 is 57, so up to here we don't want, up to there we've bypassed it. So that's the group where the median lies. So the median class is the 34 to 36 class. And that is the end of section 2.2.